Hello, welcome to my channel. We have been solving these past papers. So right now I have this mathematics, probability and statistics, and it's May, June 2024. We have already solved many questions. You can look at my previous videos. But anyway, right now we are going to solve the question number 7 here. It is the last question of this paper, this exam. Okay, so this is the question. The eight digits 1, 2, 2, 3, 4, 4, 4, and 5 are arranged in a line. Okay, how many different arrangements are there for these eight digits? So this is interesting. If the numbers or if the objects you have to arrange in a line in a order in a particular order, if those objects are unique, okay. For example, if you have three numbers, one, two, three, right, and you have to arrange them in a particular order. So how many ways you can arrange them? That is 3 factorial. Okay, because uh, for the first place you have choice of three numbers, right? For the next I have choice of two numbers only. For the next I have a choice of only one number. So 3 times 2 times 1, this is 3 factorial. Okay, so if these numbers were unique, then my answer would be 8 factorial. Make sense? Okay. Uh, Okay, so if they were unique, then the answer would be 8 factorial. But right now they're not unique. So swiping these two with each other doesn't make any difference, right? So what to do now? Okay, let me give you an example. Uh, let's see if I have one, two, 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 right? I have, and I want to see how many different ways I can arrange them. Again, if they were unique combination, then I have one, two, three, four. The answer would be 4 factorial, right? But now because of these three twos are repeating, and it will reduce my number. So what's the total number now? It is going to be 2, 1, 2, 2, 2, 2, 1, 2, and 2, 2, 2, 1, right? So only one, two, three, four things now. Okay, so how do I find this answer? I will divide this thing by 3 factorial because this is the amount because switching them around will not make any difference, right? So this is going to be my answer. Anyway, so for this particular problem, the answer would be 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial is the answer when they are unique. But since now they are repetition, so 2 factorial times 1, 2, 3, 3 factorial. Okay, so this will give you the number of different arrangements you can make with these numbers. Okay, I hope this is clear. And if you calculate this amount, it comes out to be 3,360. Okay, so let's move on to the next question. Find the number of different arrangements of these eight digits in which there is a 2 at the beginning, a 2 at the end, and 3 fours are not all together yet. This is interesting. Okay, so now I have uh, these numbers. I have to arrange them in such a way that okay, so now I have eight numbers. So first one has to be 2, the last one has to be 2. Okay, so now what choice do I have? I have to worry about 1, 3, and then 4, 4, 4, 4, 4, 4, and 5, right? So how many ways this can be arranged? Okay, first of all, uh, if I use the previous thing, then it is 1, 2, 3, 4, 5, 6. It is 6 factorial divided by 1, 2, 3 factorial, right? Okay, but now we have an additional condition that all these fours should not be together. Okay, so in how many different ways they can be together? 4, 4, 4, and then I have three different numbers, right? 1, 3, and 5. So 1, 3, and 5, these three can be arranged in a 3 factorial ways, right? Okay, now other option is that I have 4, 4, sorry, I have one number and then 4, 4, 4, and then I have two numbers, right? Again, how many ways I can make this combination? It is 3 factorial. Okay, next one is I have two numbers here and then 4, 4, 4, and one number here. Again, this is 3 factorial. And lastly, I have three numbers here, 1, 2, 3, and 4, 4, 4. Again, these are 3 factorial. So all these arrangements are not allowed. Okay. And how many are these? 3 factorial times 1, 2, 3, 4. This is all together, it is 4 factorial, right? So I have to subtract this number 4 factorial from this whole thing. So this is going to be the number of arrangements I can make with these conditions. Okay, I hope this is all clear. Okay, next question number 7C. Okay, so now uh, find the probability that these three digits are all different. So we select uh, randomly three digits from this pool. Okay, we have 8 digits like this, and we just select three of them. So what's the probability that all of three are different? Okay, so let's see. You see what kind of numbers we have. Let me make a table here. So one group is 1, 3, and 5. They're all unique numbers. In the other group, I have two twos, and three, I have three fours, right? So these are the three groups I have. Okay. Now, what are the possibilities? Okay, one possibility is that I get only 1, 3, and 5. So one number from each of these group, right? And nothing from here, nothing from here. So I get all of these, none from here, none from here, right? So how many combinations are possible? Of course, only one, right? This is one. Okay. Now, second option is that I take any two from here and one from here and nothing from here, right? So how many possibilities are there this way? Okay. So taking two from here is, there are three different ways I can select two numbers from here, right? So 3 and take this one or this one. So 3 times 2 is 6. These are 6 different possibilities that I can have two numbers from this group and one of twos, right? Okay. The other possibilities, I take any two numbers from here, nothing from here, and one from here, right? How many different possibilities are there? Again, there are three ways I can select two of these numbers, and then each one of them. So 3 times 3, it is 9. There are 9 different possibilities. Okay. Now, next one is that I take just one from here, right? So if I take any one from here, right? One from here, one from here. Okay, one from here and one from here. Okay, how many different ways now? Three three possibilities from here, right? I take one or three or five, and then this one or this one. So 3 times 2, 6. And again, this one, or this one. So 6 times 3 is 18. Okay. So these are the different possibilities in which I will get only unique numbers. So if I add them all together, 9 plus 1 is 10, and this is 24. So this is going to be 34. Right? So there are only 34 different ways in which I will get unique numbers, right? Okay, all different number. Now, how many different ways I can get from here? I mean, if I choose three numbers out of these eight, so how many different ways I will get? You know, this is going to be 8 combination 3, right? 8 combination 3, and that comes out to be, let me calculate. Okay, 8 combination 3, it is 56. Okay, so there are total 56 different ways. Out of 34, I will get the unique combination, right? So the probability of getting all different digits is 34 over 56. Okay, I hope this is clear. Uh, uh, I hope that you understand the logic of each steps here. This is very important to understand how we are doing. So the only, if you understand the logic, only then you would be able to attempt the question in the exam. Okay, thank you very much for watching. If you like these videos, please subscribe my channel. See you in the next video.